I worked on permitting. This is to solve the problem of very limited screenings for home contractors, and I'm doing it through using Open City data. Uh, particularly the data sets I use with the city of Buffalo's licensed contractors, their permit data, and also the code violated data. And I'll show you a bit how all of that meshes together. And why just the city of Buffalo? Well, that was one of the only like full data sets, but theoretically this could also be extended to pretty much any city that provides that data. So the problem with contractor vetting, if you ever worked on a home renovation project or any kind of rehab in real estate, is that they're all over the place. A lot of them are just one person, two, 8-person businesses that don't really have great record keeping and don't necessarily keep a very like tight history. They're just kind of like shoddily run businesses, but they maybe drip still. And traditionally, if you wanted to, actually, let me start with a personal story. I recently completed a home renovation project that was about a $200,000 project. But my general contractor didn't vet any of his subcontractors, and it turned out one of these subcontractors, the junk removal folks, they actually ended up damaging my neighbor's property. It was almost ended up in a $100,000 lawsuit. Luckily, it didn't actually get to that point, but there was a lot of cleanup to do at that point. A lot of it was just post facto background check of these folks. So the problem with traditional background checks on contractors is that yes, you can verify that they actually have a license and that it's active, but that's pretty much it. It will not give you any kind of behavioral history, such as how they performed on previous products that they pulled, or if there were code violations that resulted from those turns. Additionally, we have traditional background checks that go into criminal screenings and drug tests. These are actually really bad indicators because a lot of the time they don't really have anything to do with the actual project. DUIs, for instance, are the most common type of criminal screening kit, and I would argue that that has absolutely nothing to do with the performance of a contractor, their workmanship. In fact, there may actually be a negative correlation. Sometimes folks that are really, really good at home contracted work may have actually been incarcerated before. Same goes with drug tests. That's another traditional screening. They're extremely expensive, so you wouldn't want to do that. But they also may have opposite signal. Some of the best contractors I go are a little bit high too sometimes. And then employment and education obviously is one of those like negative signals. Most of them didn't actually go to school. Most of them are where that it's going to be really irrelevant to look at their employment history, especially as independent contractors. Turns out city data actually contains a ton of really relevant information about how folks like this have fought. So, and one last thing is that I haven't had relevant experience here. I used to work for a company called Checker, which is a background check company that did all the background checks for Uber, Lyft, DoorDash, etc. So anybody that you've ever ordered on an app, we did background check though. I also worked at Chai, which is the largest consumer fintech in the United States, and so I've been vetting people for the last 10 years. Okay, so so this is a demo of my solution. So we got into permit it. And the idea is that just simply pulling together all that city data for permits, so we can get a sense of. Okay, so this is one that I happen to know has kind of a high risk, and so these are essentially preformed background checks on city or home contract use. We look at essentially red flags, and the reason why this was not really that possible before was because before using AI, it was really hard to correlate. It would be extremely time-consuming to correlate code violations with permits and tracing that back to the licensed contractor. So what this does, sorry, yep, okay.
Very good.
Hi, I'm Priscilla.
I'm David. And I'm Keshav.
And we are Lattice. Every day, we wake up and we go on our phones and we have access to the internet. We scroll on Instagram, we scroll on TikTok, but some people don't have this privilege. New York is one of the wealthiest states in the country, yet, right now, over 1 million households are completely disconnected from broadband internet. At the same time, 64% of all New Yorkers live in a child care desert, and over 36,000 people in our rural counties are trapped in an absolute food desert. These are not isolated problems. When a family lacks internet, they often lack access to food, transit, and education. These problems are deeply intertwined, necessitating the aggregation of multiple datasets to assist lawmakers in making the most informed decisions they can. To solve this problem, we built Lattice. This is an equity-first resource allocator that analyzes data and tells policymakers exactly where and how to intervene.
Policymakers often are not equipped with the data required to make the best decisions that they can and allocate their resources, money, and development time to the places that need developing. So we have taken the opportunity to analyze 5 whole data sets. One on fiber coverage surrounding broadband internet, and then linking to that, we have food stores to identify different food deserts throughout the capital region, as well as access to childcare, health, and business development within each county in the capital region. We can see right now the dots are all demonstrating different counties that Lattice has analyzed, and they all have an ROI score representing how well a policymaker could expect to improve the lives of people there by investing money. For instance, in this county, 12303, they have a reasonably low poverty limit, and they have lots of transit stops, but they have a fairly large broadband gap. And we can compare these to all the other counties and locations within the upstate New York. For instance, we also have the ability to identify AI-generated reports, which take in data that comes from all of these different data sets, mix them together, and then allows us to compare how well the different counties do to each other. For instance, this one has a pretty high ROI score because of the low childcare access within the county. So a policymaker could simply easily look at Lattice and then identify, I want to help this area get more childcare access via subsidies. Additionally, we have policy recommendations and data sources, and the ability to download reports for policymakers to use. Some of our data comes from the NYS childcare regulated programs, from the NYS detail food, from the FCC's broadband maps, from various other government data sites as well. And these are all aggregated in-house.
Yeah, so the tech stack we used Stitch for creating the designs, and we use Google AI Studio and Codex to generate our website. And we use ChatGPT and Gemini. We use ChatGPT to help us create prompts and type prompts into the engine. Yeah, so we plan to partner with local organizations like NYS Tech because they already have all the resources and the connections. They already partner with a lot of government agencies. So, and we want to deploy and partner with other local governments as well. And then after, we can collect feedback from these policymakers and community organizations for our reports, and we can refine our model and continue to improve. After, we will also create a subscription system for policymakers to access our detailed reports and insights. And after, finally, we can scale the company and its data to more states and regions. And these are some of the prompts we use. This is one of the detailed prompts that we created to create the report. Thank you.
Moving can be an overwhelming process. Finding the perfect school is just one of many issues that families have to consider. To lighten this burden,
we utilize tools like school datasets given by different government agencies and Python Flask to show this on our website.
so what's the problem? Every year, millions of parents have to choose the right school for their kids, which is one of the most important decisions they'll make. But the process is frustrating. Often, information is scattered across different websites, it's hard to compare, and often is not easy to understand. This becomes especially hard for families who have to move and are not familiar with the given area. Why this matters. Choosing a school directly impacts the child's future. Parents need clear and reliable information for this life-changing decision. Right now, the data exists, but it is scattered. That introduces perfect fit.
This is fairly simple. The UI is designed to be very easy for parents to pick up and easily digest all the information for whatever we intend it for. They can go on the website, search for whatever they desire, and filter it on the panel. It's same like as many sites you would find for locations. And there would be big blue buttons to apply them, and it would show only those filtered options. In the middle, there's a simple map with clear pins to show them, and when a pin is selected, it also consolidate information for that entire school.
All right, hey guys, I'm Owen. I'm here to take you through our live demo now. So here's our site, Perfect Fit. So first, when you log in, hop on the home page. It's going to give you a nice little layout here. So mainly what you're going to want to do is go straight into your searching process. So let's say initially that we're looking for, let's say, a school with the zip code 12180. So right here, we can search by schools, and we'll see that the one school in that zip code area is Troy High School. So we'll be able to click on it, and we get some statistics here on the right side of the screen, talking a little bit about the school. And there's also a feature here that we have where we can favorite or unfavorite a school to add on our list. And alternately, let's say we went to a school, Whitesville, on the New York, Pennsylvania border. We can type it in, the name of the school, the city of the school, or the zip code. And ultimately, that is going to allow us to get the same features that we would when plugging in the zip code. You see the same type of statistics here, as well as a feature to remove our favorites or add to our favorites. Whoops. And then once on the favorites page, you can compare and contrast your different types of schools that you've selected, and as well as possibly move them for ordering purposes if you needed to later on. I'll bring us back to the slideshow. All right.
Now, Perfect Fit's target audience is parents who are moving or either they're looking to buy a house. And now for these individuals, proximity to a good school is going to be a very important factor in that decision. Naturally, you'd think that Perfect Fit would be in competition with services like Great Schools, which you can find through like Zillow. That's actually not the case because Perfect Fit provides a more holistic view of these schools, and that's sort of actually lacking in the current solutions that are on the market. Now, these things that make good schools, they're not just test scores. It's also like extracurriculars like music and arts, athletics, and then other STEM programs that you can have access to. So naturally, what's going to happen is that Perfect Fit is going to enable parents to have access to a greater depth of information about these schools when deciding where to start their child's future. Here's how we're going to expand our product in the future. First of all, we would like to include schools from different states instead of just New York. We are planning a feature that school districts can use to, across like various metrics, compare themselves to other school districts around them. Additionally, we are thinking about maybe like a premium features or like an AI helper to help counselors or parents like advise their students.
So we used a data set to first take IDs from different schools around the New York State area and then connected it to school sets that had resources on it. That's mainly how we use the open data.
All right. Hello. So we are GoTo. I'm Zachary. I'm Eric.
I'm Wayhel.
I'm Matthew.
And so I want to start off by one thing we wanted to take a look at is how the transit system currently is based around moving adults to the transportation. But we wanted to focus on bringing the transportation to the adults. So our problem is that transit deserts are typically located in low income and like car-free adult regions where it makes it difficult to transport to educational services or workforce programs. For instance, right, like let's say you're an adult, you have a GED program, and the nearest bus stop is like 3 miles away, right? And you spend $22 taking just like an Uber or a car ride just to get to the bus stop, and then you go from there. Or even, right, your trip in total is like 2 hours when we could probably optimize that with better transit routes.
All right. I'll go over the 4 datasets that we used. The first one, it's the CDTA published schedules dataset, which we just pull data on bus GPS coordinates and the wait time. We calculate wait time from those coordinates. We also use the NYSCD facility locations dataset to find where the adult education sites are around the capital district. We also use the Census ACS 5-year estimates dataset, so we can collect data such as car-free house percentages or the median incomes, so we can prioritize routes for most vulnerable individuals. And then we also use the OpenStreetMap dataset to accurately follow actual street routes instead of just drawing straight lines.
So this is happening everywhere. So just from the Hudson Valley community, we saw that 14,000 adults have to take take 45 minutes just to get to their destinations via a public transport. It takes around 52 minutes on average via public transport to get where you want to go, compared to driving, which only takes 12 minutes. That's a 5 times increase in transportation time just to get to your average location. So how exactly do we build it? We're going to highlight our 2 core features, which is our interactive GIS map that has layered overlays. And we're also going to highlight our AI route scoring engine, which is how we score which routes are more important to build than others. So how exactly is AI used? Number one, our route scoring engine uses AI to calculate which routes are better than others to build. Number two, we use Perplexity Computer for a lot of the designing and building of the website application. And finally, we have Gemini Analysis Panel, which analyzes each one of the routes to make sure that they're optimized for both efficiency and cost effectiveness. So this is just a demo right now. So as you can see, there's a lot of options for each one of the transits. So there's adult educations that are serviced by transportation, that are not serviced by transportation, and that are limited. We also included CDTA, which is the local bus routes, just to make sure that we don't overlap with the already existing bus routes. So some other stuff that exists here are the transit deserts, which are areas where you have to spend over 45 minutes walking just to get to your nearest bus stop. Other stuff added are hospitals, schools, colleges. These are important for transportation. And then we also have suggested routes, which are what our AI is how we use AI to suggest routes. So let's just go to sites. So if you click on one of the sites, it'll give you a description of the site as well as the nearest bus stop to the site. It also tells you the median income and those nearby. If we click on one of the deserted sites, we see that some of these stops have no bus stops for over 8 miles, which is insane. Same destinations are just some of the possible destinations. And then AI routes also similarly give you just a brief overview of which routes should be built, how much they cost, and the score or relevance that these have for the community. So I'm Eric. I focused on the platform lead. Matthew mainly focused on data. Zachary focused on the front end, and Weihao focused on the scoring.
All right. So some of our future plans is to use Live Gemini API to replace our rule-based system with a more contextual plain language system. And there were 2 features which were suggested to us by Richard, which was to factor in foot traffic and live heat maps for like pre-existing transport. Because it's like there was situations where it was like, oh, if you go east and west, it's like 15 minutes, but then coming from north, it's like an hour for no reason whatsoever. And we also like to eventually expand our services to cover more than the capital region, to cover the whole state altogether.
Thank you, everyone.
My name is Kevin George. We have Prem and we have Karthik obviously. So, how many of you have tried to look up where the New York City budget's actually being spent on? Anybody in random guesses? Like what tools you use? Anything like that? Any tools or websites? All right. So for the 2027 fiscal year, it's been about $114 billion. It's public and it lives under 32,000 row spreadsheet that nobody can make a sense of. Journalists cannot use it. City council members don't have enough time to fact check or verify, and the regular citizens don't stand a chance. So we build Budget IQ, a conversational artificial intelligence tool that lets anyone ask the city's entire budget a question in plain English and get a real answer with the chart under 2 seconds. And here's the core problem. The New York City's financial year 2027 budget is fully public. It's on the website, but it's split up. It's split across two massive data sets. It's a very massive CSV file, which the regular citizens cannot make a sense out of it. The journalists cannot fact check it. So we validated this with the journalists, budget watchdog groups, and even city council staff. They all said the same thing. The data is there, but it's practically locked away, public in name only.
Just to give you a perspective, I came across this Reddit post yesterday. That's where your money going. So you better know where your money is going. So as my friend has explained, that dinner budget is public and it's practically inaccessible. And what we have tried to do is we used a tech stack of building a RAG pipeline, and we ingested and used vector databases in order to do a semantic search on the CSV files that we have, and used conversational AI in order to make it easy for even for the layman to converse with the AI and get to know where their tax money is going on. So I have built the architecture, and he has built the front-end design, and he has given the ideas on how to give the solution. And just to give you a demo, how much did we spend on healthcare? Just give me visualizations. Oh, perfect. So I used 20 cents for this. How- Perfect.
All right. So this is the small prototype that was built, and we are actually releasing this application on 3 tiers. One is a public tier, which is free of cost, and the other tier is for the journalists. It's like about $99 a month, and the next one is with the government agencies, about $2,000 a year. So we're expecting about $600,000 as our ARR, annual revenue, and so based on the capital that we're investing, we're just focusing on the major metropolitan cities. But if we get more revenue and more capital, we are trying to expand it across multiple states, multiple metropolitan cities, and eventually scale it globally.
So basically, our goal is very simple. So we want to all the people aware of what the budget is going towards. So many people here, like we are all paying the taxes, right? So we want to aware that how their taxes are paying and towards what they are going through. So our future plan is simple. We want to expand this to all the metropolitan cities, and once we achieve that, we want to go it through the global stage, and then so that all the people can have access how the government is spending their own taxes and towards the people.
Thank you and have a nice.
Hi everyone, I'm Chibu.
And I am James.
And our solution today is called Pockets, and our theme is don't guess it, just park it. So what's the problem? We think this is a very common problem that everyone faces, and that's you're going to somewhere new in the area and you're not really sure if you're going to have parking space. You could have been invited to a friend's birthday. You could be going on a date. Personal experience on Valentine's Day, it was horrible for me. I didn't really plan properly because I didn't know I was not going to have parking space, and I spent like 10 minutes trying to just get parking space, and I apologized to my girlfriend for an hour. So parking basically saves you time. It saves you precious time through the day when you're commuting somewhere and you just need to park your car. And in the Hudson Valley, we're able to get this data. So 30% of traffic or people just looking for parking spots. You burn about almost $350 a year on parking. I would need that money to get myself a new phone. You waste about $7 a year on parking. I will need that time to binge watch my Netflix shows. And they say 63% of us are frustrated. I'm definitely not among the 37%. Okay. So our target is, everyday people, just urban commuters, people that are trying to, drive in someplace and just need to park. We also have this solution for city planners that also want to improve, the parking logistics in the city just to help the everyday citizen. Um, and so our solution uses AR. So basically what we do is before you leave your home, before you go somewhere, you're able to have insight into, available parking spots. And this is at a granular level. So you know exactly when on the street you can park, you know where, which direction you could go, you know the navigation route and all. And we've not implemented this, but you're going to be able to be directed towards the best parking spot for yourself. Okay, so basically we use an AI agent that runs a vision model and basically it gets some context on like pictures that we gather from street cameras. And the data set we use is the 511 New York State data set. Unfortunately, when we're implementing our demo, we needed to have gotten approval for the demo key, for the API key. We're not able to do that. So rather we simulated some streets. We're able to simulate some data from that data set, basically just pictures of cars on the street, and we used our agent to infer parking spots from there, and we're going to show you a demo. Okay, so use cases: shopping centers, event venues, campuses. We can integrate this as a web application. We could run APIs to third-party developers, navigation systems, and of course this should also be a public application. So we're just going to show. Oh, yeah. But these are okay. You can use the QR code and just go to where our solution is hosted. That's the password my drop site. So all you need to do, just put in the street number and house on the street number and address of wherever you want to go to, and you're going to see a demo of just how our solution is going to basically analyze the scene and tell you, okay, these are the number of cars, this is the traffic situation, you should probably not park here. You should look for some other place. And so the future is that we're going to have an interconnected system, um where we can even crowdsource the data. So we could have it could become a community app where the everyday person can, you park somewhere, you could take a picture of your location, of the street around you, you just upload it to the app. It could also be automatic, and basically our AI model is going to fuse the data and help someone else who's going to come around the region to have a good parking space. Okay, my bad. So that's it again. If you wanna suspend it. Uh, okay. So we're trying to connect it to we're trying to connect it to the laptop, but our laptop is not connecting to the projector. But please feel free to meet us after this if you want to say it. But we're gonna go check why it's suspended and make it active again. But just take a picture of the QR code. So finally, we have a roadmap where if you have like an electric vehicle, it could just check into the API and basically have the parking space and just drive you to the perfect space to get parked. We could also have spaces that have EV charging if you need to charge your vehicle. And obviously, just apart from the capital region, we would like to expand this to, so many cities all around and make this a global application. Thank you very much.
Okay. Good afternoon, everybody. We are Rolled Pulse. We don't know each other very well, but we did build a little something for y'all to check out. We think that the big problem with all this open data is that you're looking for a needle in the haystack, right? And no one really knows how to aggregate it, especially if they're not a data engineer. And so the decision makers in government who want to spend money don't really know what to do with it, and they have to hire a team, and that takes 2 years, and there's a committee, and it just takes forever to get to your fixed traffic light or, new healthcare center. So we tested out an idea of how to pull in the data, and we solved, some traffic problems right here in Troy. The idea was, a decision maker wants to figure out where's their high ROI, because there's a million places you can spend. And it's like, there's traffic fatalities, there's people dying. There's time down where a car gets damaged and your truck isn't moving. And then there's citizens who are complaining that, hey, there's no stoplight that's working here. So we pulled in from the DOT and the DMV. And it's a surprise that these are two different data sets in some ways, because this siloing of data is part of the problem that a decision maker has. We also noticed that these data sets are totally incomplete. When you go to build something, you would think that a traffic accident might have like a latitude and longitude assigned to it. Nope, it's just like a vague general notion that it was on like Route 4 or Interstate 9. It's like, okay, that's not exactly what I
Mile markers.
Mile markers kind of.
The mile markers are not geocoded, apparently.
And so it's really hard to like figure out, hey, if I had $1 million, where would I spend it to save lives today? So we figured, hey, let's unify the data and reveal the gaps. Because once the gaps are revealed, maybe we can crowdsource this. And maybe we can crowdsource this with like a market mechanism, so I know how much money this intersection or area costs me yearly, and then put a price tag on it. Hey, maybe us, the city council, can allocate $1,000, $10,000 to bring some citizen, some company to fly a drone nearby and give us an idea of like what the hell is going on, so we can get the ball rolling and spend these tax dollars efficiently. So our display is pretty simple. Everyone uses a map. It's basic GIS stuff here. But we tried to highlight, a hot point. Here we see that there's like 725 crashes that we estimated vaguely may have cost $37 million over 4 years based upon some insurance data that we pulled in. And then we figured out like, hey, this is what the high ROI would look like. Do we need streetlights? If so, you can click on the streetlight and like, we need someone to come by here and we will pay you $25, $500, some number that we'd have to figure out to get the information to bring the engineers on board. This is just, a prototype of a general idea that data needs an economic value to be useful to a decision maker. If you're trying to like, spend those hard-won taxpayer dollars to make your constituents happy, you better know what's going to be useful to them. And we figured that the average, decision maker is more likely to use a map than a bunch of, SQL queries, etc. And that is the nut of it. Anyone else want to explain the project in general?
And just the integration of crowdsourcing, of an opportunity to bring people in from the community to be able to find what the needs are, actually go geotag, take pictures of things, bring the data back to the database where it can be looked at by the decision makers.
What you see here are the dots that are on here. They're not perfect locations, but they are accurate, estimated within like 2 miles max, sometimes less than a mile. So they are somewhat accurate, but because the mile markers aren't geocoded and it's based on mile markers, we only have a rough idea. But it's an opportunity to incentivize, possibly crowdsource people to collect that data, and that could potentially be monetized.
You should. It's us.
I think you guys covered it. That's about it.
I mean, that's none of it. This isn't exactly rocket science, but the big picture is all this open data doesn't help anybody if you can't structure it in a way that a decision maker can use it. And talking to it via chat. I mean, someone built something really nice. You guys, I liked your approach. That was clever. Is a good idea. Yeah, that's it.
Hey everyone, my name's George. I'm a self-taught developer that used to be a mechanical engineer.
Hi, my name is Aryan. I'm a new graduate from Penn State.
So what is the purpose of Bird Squad? The purpose is to fulfill your passion for bird watching. And how does it work? We're using an API called eBird that local people report on bird sightings. And then we'll show you the demo and our future plans. So it simply uses your local location that you can put in or search your local area. You can share what you find and share with other people. And you can sort it by, if you're just interested in a certain species, you can find that way too. And some of the benefits for just this app to the public, we just have studies that looking at, nature and birds just makes you a happier person. So that's always a plus. And targeted, another study found that targeted bird watching reduces distress more than just like a walk or like a hike, because they're kind of looking for something instead of just zoning out basically. And another utility that I found from our mentor today, Alexandria, she has like some
local expert at her library that does local tours. And I had no idea about him, but apparently he's a big star in her community, and I would have loved to know about him. So if he was on our app, you guys can find him, and he like does the whole tour. He has like a scope apparently. I don't even know what a scope is, but you see, there's local experts that want to share their passion. So this is what the app looks like. We'll have a demo a bit later.
Is not.
Sorry. Go ahead.
Yeah. So this is a like you said, this is a screenshot of the site right now. It's actually a website, and it's designed to be very intuitive. So on the left side, you can see like various filters. You can filter by the name of the species, and also filter by the location. There's two types, which is the current location or the state location. And you'll see the results on the map, this OpenStreetMap. And again, the data is from the eBird API from Cornell. And on the right side, you're supposed to see the pictures posted by the exact users and the results you got. However, we're using prototype images at the moment. And on the top is where you can essentially plan out your like bird watching group event. So if you kind of pick a pin, then that's where you can like schedule and essentially invite like let different users to go ahead to the event with. And yeah, essentially we actually at the start we built 3 different prototypes. One using Google's AI Studio, and the other two on VS Code using Gemini and Claude Code. And essentially we kind of combined the best results out of each of them. And the front end is using React with TypeScript and Vite with Tailwind, and using Node.js and Express for the backend with again the eBird API from Cornell for all the data.
So just quickly, you could not put in your location and just use the tab, but I will say, give it my location, and it automatically found the local sightings from today. So I'll put in our state as well. We're in New York. What did it find? Well, there's some turkey vultures over there sighted by someone, and someone else found the American kestrel. And let's say you're a local expert and you want to meet up with people. I'm not sure if there's any other apps that let you do that, but I could join the group, leave the group, see what other people are up to. Not all of these features are 100% implemented right now, but this is basically the gist of things. And also there's like a trip planner as well if you want to be the host. And yeah, like I said, not all the features are in just yet, but features we would like to implement is just better trip planning. So maybe you want to see 2 species today instead of just 1. So you can make a little planner there. Better social media features. I want to add that local expert that I talked to. Follow him, see what he's up to, if you can update stuff. And obviously, mobile apps are just the way right now. So that would be the next step. Thank you.
Hey, good evening. My name is Victor, and we got Jake, Drew, Rafi, and Sadiq. I'm an Ulster Bosses teacher, and the problem that we have is we prepare all of our young professionals for a workplace environment in a workplace setting, and in the end, we do not have the transportation in rural Hudson Valley to send them over to workplaces where they can get a real world experience. So only students with cars, the rich students, can access the internships, and oftentimes the employers cannot find the students that have experience and that are certified because they can't get to their workplace.
So for our solution, we focus on Ulster County. So we'll take a look at the solution right now. So this is what Ulster County looks like. Yeah. So we go. It's an hour and a half from here. So this is where Boses is, and this is what their current transit looks like. Yeah. Or what's that? Oh, there. Nice spot. So this is what their transit looks like, and these are where the students are located. So there's a mismatch between where the transits are and where the students are located. And these are the workplaces, the mom and pop trade shops that they are working in. So there's a gap in it. So how we are planning to fix this, we are going for a two-part solution. First, the county is willing to work, and so what we're doing is for these 500 students, we are offering a proposed bus stop that a tweaking 3 to 4 bus stop is going to cut down that 500 students that they have right now, the seniors, into a little part that we could be focusing on. And then BOSIS is also looking towards rolling out routes that 3 or 4 routes would be able to help and tackle 80% of the other student population that they are right now that they need a ride to do their work. So this is what we have. We are offering for Ulster County. It's like we have niche down to just them, and we have like 4 buses route, 10 new stops, and that's going to cover 122 students that we could not work with before. So this is what we have for this. And this is what it is. And we can see like how BOSIS is at the center of the downtown and everything else is pretty scattered. This is where it is. So getting back to the part of the solution. Sure. For the tech part, we use Flask backend or React frontend, and we use Leaflet. We use a lot of the county, Ulster County and the GDFS for the data, and a lot of anonymized data from BOSIS, thanks to Vector for that. And for this is the before and after that we got. And for the future plans, Drew, do you want to? Yeah.
Yeah, so for our future plans, we plan to actually pitch it to Ulster County BOCES. And we also plan to expand this throughout all BOCES throughout New York State. And beyond that, we might just try to pitch it to other states that have similar programs. And that's it.
That's up in this center.
Okay. The problem that I've worked on is childcare deserts. There's a new $20 million that's been given by the state to Dutchess County to expand childcare for 0 to 3 years old, especially. So that's what I decided to focus on. And this is made by Notebook LM. So there's a lot of different ways we can fix that. We can build new facilities, we can expand existing ones, and we can increase wages to fill the existing facilities which aren't fully staffed. So basically took a number of open data sets and then process that using some LLMs to make it structured. And then now we have a tool that can be used for the government to figure out exactly how they should allocate this. So we've got a budget planner here, and this works for all Hudson Valley counties, but Dutchess is the most relevant because of the budget that's just been allocated. So we can slide here, and there's a constraint optimizer that will figure out, given some basic, first order estimations on cost of expansion versus building, all backed on historical data. What's the best thing that we can do to decrease the number of deserts based on the Dutchess County definition, which is a ratio in these tracts. So then we can do this, and you'll see how many, like what it decides to do at that budget level. What's the optimal thing given the constraints. So basically it's based on a number of data sets and then some LLM preprocessing and preprocessing through the constraint optimizer so that it's not doing that in real time in response to the user's actions. And then we get actionable outputs. The increasing the wages is this number based on some previous experiments to see if they could fill more slots for teachers, basically by supplementing their wages, because that's a significant problem at the moment. And this is my team, myself, Opus 4.6 and GPT 5.4, with a shout out to Notebook LM. And essentially what would happen from here is to have a conversation with Dutchess County, and then from there potentially do some real-time monitoring and allocation of that nature. So, thank you.
Hi, good afternoon, everyone. So I'm Heyman. This is my friend Mani. We are here to present something about which we worked this afternoon. It's City Oopring. So a quick question. Raise your hand if you're wearing a fitness tracker. Oh, here. Anyone? So what fitness tracker are you using right now? Apple Watch. Does anybody have Whoop Ring or the Samsung Ring? Cool. So yeah, great. Has your tracker ever told you that air pollution is why you slept properly? I mean, air pollution is the cause why you haven't slept properly last night? Does any of your tracker told that? Anyone? No, right? So because the variables which we wear every day ignore the city around you. So we built woofing in such a way that the first variable which connects your body with your environment around you. So we all know that urban environments are silently damaging the health. So we can see that 9 out of 10 people breathe polluted air globally everywhere. And there are 68% higher cortisol levels in high noise urban areas. So if we have an area with high noise pollution, we can observe that people are really stressed in that area. And also, uh, right now the cost government is spending on this problem would be somewhere around 190 billion, which is way too much. So the reason which we believe that the problem exists is we get the data from New York 311 noise complaints. Does anybody know what is New York 311? It's something kind of 911, but it only takes not the emergency complaints. Like if you have any noise pollution around you or if you have any municipal problem going around you, you can raise a complaint by using 311. So we get the data by using 311 noise complaint, APS, AQS, EPA Gov, and 311 noise complaints and all. So our solution to this problem is we are focusing on 3 steps. The first step is input. So we are getting the variable data like the heart rate, sleep stages. You all know, right? People who are using Oop band may have the better idea of Oop band or the Omega ring. So it tells us at what time did you wake up, at what time is your snoring level high, and at what time are you peacefully sleeping. So it tracks everything. Since you all know, the person who's using can know this. So we are trying to add that one with the sensor data fusion and time series modeling, and we are getting the data from urban health score and smart route planning and all. So my friend Mani will explain how CityOop changes with the lives and systems.
Yeah, TTOop is nothing but like it is not just a variable device. It actually connects, your life with your surroundings. For example, like individual like me. So like you or like me, I should not have more concentrate on like how air pollution around me or how like sound pollution around me. But it actually matters. It actually matters of your health. So my Oop variable device, it will depict like how changing habits in around the environment. Suppose it is also used for a government purpose. Like to trap off this data, government can invest on money like at which we can depict like at which we can increase our health.
So let me take you to the live demo. So this is our web page. Oh, why is it not displaying? Oh, we're planning to open.
Yeah, it's
Okay. So this is our website which we built. So if you can see right now, we don't have the physical device, so you can't see any score. So let's take a live example. So we all know that the busy street is Times Square. So any guess how many hours people in Times Square streets? Probably less than 5. Let's see the stress. They're actively stressed. So if we try to analyze the health factor, this produces these insights. Like we have the
physical score, we have the bioresponse score based on the accurate reports which are happening lively in Times Square right now. So based on our current biometrics, like the sleep schedule and all which we have uploaded, we can see that it shows us ideal avoid outdoor activity between 2 to 4, because that's the peak time when we have more noise pollution and more air quality index is very high. So
Hi, everybody. We are Nice Bus. I am the team manager and designer, Ahona Mukherjee. Would you like to go?
Davey, I was a prompt engineer and front end developer.
I'm Noah. I was a data engineer.
I'm Garrett. I'm a prompt engineer and front end.
I'm Lama. Any engineer, AI engineer.
All right. So I would like to tell you guys a little bit of a personal story. A week ago, I crashed my car in the city of Poughkeepsie. So now I don't have any way to travel other than using the bus to get to my workplace. That would take me about an hour to get to my place of work. That is 63% more compared to the 20-minute amount of travel time that it would take by car. Now, let's think about that if I had a stroller. It's a 40-minute walk time to get to my bus stop. What if I had a wheelchair? There's hills like crazy going to that bus stop as well. So we need to think about how exactly transportation use affects the people of New York State. In the capital region alone, 1 million, I'm sorry, what? Yeah, the 1 million people, the CDTA serves over 1 million people, and it makes 3,000 stops. In addition, there are several obstructions that cover these stops as well, so these stops aren't even accessible. So, and budget is also a constraint. Many people do not have the ability to afford these bus trips on a regular basis, right? So, how do we solve this? Oh, go ahead.
So I'd like to talk a bit about some of the value and justification. Firstly, regarding geographic gaps, many of the best specialized transit apps, the best one we could find was City Mapper, only worked for a specific set of cities. And along with this, there are also filter limitations. So we can't um, usually look at cost and accessibility all at once, as well as monetization barriers. Um, so high quality features are often sort of limited, basically.
So we want to study this by finding one, accessible routing for all different types of people and filtration systems that essentially accommodate for those access needs. We want to also address budget constraints. In addition to that, we want to highlight transportation issues for policymakers by highlighting red to green zones, saying that is this area high cost? Is this accessible? And marrying these two factors with open data. We also wanted to ensure that our scope was limited. We designed particularly for a student who is a wheelchair user with a budget constraint. So to ensure we are keeping our focus in mind with those ideas. So we'll do the demo and show you exactly what data we used in order. And while we do that, does anyone want to explain the tech?
All right, so this is our demo. So we are working with the CDTA around Albany for our data set just to test this out. And we can put in any stop around Albany that we're interested in. So right now we've got, let's put in a different one.
Albany Apple. 1 minute.
All right, Airline Drive to Executive Center. We'll find a new route. It gives us a route, we get the cost breakdown, we get the time breakdown, and also comparison of different routes using the bus system and walking around Albany.
And on the side, you could see we have a AI resource finder, so we can you can prompt it and it will give discounts for different routes.
So
So we gathered GTFS data, and basically we created a graph. So the graph was for the stops, the bus stops, and we find the routes using A star and Dijkstra, and that basically we can use a cost estimate or a time estimate for any reduction that we wanted to either in cost or time using those algorithms, and we find the shortest time.
Hi, I'm Red Route. I'm Tazim, and I built the Safety Aware Commute Companion for RPI students as an RPI student myself. Who here feels safe in campus? Most of you do. Oh, I see some hands. But like during the nighttime, it can be a bit unsafe, right, to travel across campus, even in like downtown Troy. So here's a stat: 76% of pedestrian fatalities happen in the dark. Safer routing matters. 62% of pedestrian fatality hotspots are on roads carrying 25,000 plus vehicles per day. Red Route avoids the corridors most associated with pedestrian deaths. This is game changing. The data for this application was all pulled from the New York Open Data, and now I'll show you a live demo of the app. So this is the landing page. As you can see, I kind of show all the data here. We use data from the shuttle, CDTA, and all the open New York data, such as the crash history, to make this algorithm as accurate as possible and as safe as possible as can be. So right now we're in the DCC. I'll put my lab location as on and detects that, as you can see from the blue dot. And let's say I'm going to my dorm, Blitman. I can type that in, hit search, and now it's building the red route. The red route isn't necessarily the most fast path, but it's the safest path. And as you can see, it recommended a direct walk. So it also has like the second best option, which is the shuttle. But for the first option, which is the direct walk, this is the safest because it avoids roads. And you can see more detailed information here. It uses, so the shuttle is live right now. So it uses shuttle data, it uses CDTA. Well, CDTA is not used because it's within RPI campus. The coverage is tier 1, and it uses all this kind of data to tell you the total travel time, the walking time, there's no wait, and it gives this rationale, right, with high confidence that it's lower crash traffic and disruption exposure, and that it's the most direct option with no transit wait. So it also considers the time that it takes. The second best option, it puts this as 67 on safety as opposed to 79 on safety because of the exposure to the road. And 15th Street corridor, it detected from the data that it has a stronger history of more crashes. And from that data, this algorithm gives you the best sort of like predictions. Now, let's say I'm leaving night. So the nighttime, it tends to be more unsafe. So let's say AM and 1 p.m. Turn the live off. And let's say we're leaving from a different location. So Folsom to City Station, which I know many of you are familiar with, is not the safest at RPI. So let's do this. Hit enter, and it's building the red route using the advanced algorithm, which I'll go more into the tech stack. All right. Yeah, so as you can see, like even though it's night, it recommended a direct walk because like the CDTA, it's often not even active during the midnight, and shuttle is not even an option. So if you go to details, you'll get a complete analysis on the whole sort of rationale behind it. So it says crash history is estimated, traffic stress, and the riverfront has higher pedestrian crash burdens, etc. Now, the stack that I used was primarily a Next.js stack using Macbox, NPM, and all these different external data sources that you can see here in the orange. So NYS.CETA, Shuttle. So RPI Shuttle has its own API. I use that. It's part of Arcos. NYF11 events, New York Open Data Portal, and New York State DMV crash data. And I use the Socrata API to prevent rate limits. So right now, other apps such as Rave LifeSafe are only reactive, right? They don't actually like help you predict what's unsafe. And Google Maps is only efficiency focused. It doesn't focus on the safety of a route. Transit apps such as the CDTA and Shubble are transportation focused as opposed to the user focused, which is very pertinent when it comes to safety. So RedRoute is uniquely differentiated within all these different kind of platforms for being the only proactive safety optimized campus navigation solution. Future plans is to work directly with Rensselaer, particularly PubSafe, right, with a strategic kind of partnership offering real-time emergency incident integration. And if it's really unsafe, so no paths work during a specific time, it automatically calls PubSafe, and you can just like go to your dorm with the safety of PubSafe. And after successful pilot at RPI, we will plan on branching out to other schools within the Troy district, such as Siena College and HVCC, while also improving the technology. And that's it. Thank you.
Hi, we are Eagles. My name's Matthew Voinovich. I am the AI engineer.
My name is Amaya. I work as a backend engineer.
I'm Swaroop. I was the front-end engineer.
I'm Matthew McCall, and I'm the hardware engineer.
So Eagles is a platform that's designed to try and detect gases and other hazards early before, because they're hard to see and they're invisible. So I will get into the dangers.
Yeah. So gas leaks like CO2 and methane are invisible killers. You can't see them, you can't smell them. And right now, even when detectors are networked, that data lives in its own silo. When an alarm sounds, there's no connection to the known environmental hazards already documented by the state. Workers and officials are making decisions with half the picture. What we're building changes that. Our system connects a portable Arduino Nicholas Sensei Me gas sensor to a real-time dashboard that maps uh, live readings directly alongside New York State's environmental remedia- remediation database. So when a sensor triggers at a job site, you're not just seeing them or seeing an alarm, you're seeing it in the context of known contamination sites, site classifications, and historical hazard data. We're breaking down those data silos and giving workers and officials a unified picture they've never had before.
So I'll get into a quick breakdown of our technologies. We used for code generation, Claude Code, Copilot, Gemini, etc. We use Next.js, Supabase, React Native. For data, we took from data.newyork.gov, specifically the remediation sites, and for hardware, we use the Nicholas Sense ME. So our our plan was to have edge sensing with the Nicholas Sense ME and have, when it detected data, push it to your mobile phone to give an alert. It will have GPS that sends it then to our backend. The backend would then aggregate with the New York State data to verify and connect it to a specific remediation site. And then that dashboard would also contain more information on said sites.
So currently we're using open data to show different parts in the New York State and saying like where specific locations are exposed to like different types of gases. And we hope to also leverage this data to train our own model such that like we can go in person, kind of like manually test this as well to like keep our data even more up to date. And in the future, we're hoping to have real-time data that can like train our model through our website itself.
So I'll move on to a little bit of a demo. This is an example view of our dashboard, but let me. So here is, we were unable to connect everything fully, but here's what our test data looks like from the open data. We have a regular pinning. We have a heat map for everything. If we scrolled out, you'd see it gets stronger, and we cluster all the points. I will move on to our hardware.
Yep. So
Do you want to alt-tab to the nice viewing?
Do you want to do this one?
So this is our original, or this is the finalized front end that we plan to integrate everything into. It was a bit of a challenge with all the hardware and the data as we were split up very strictly. It has all the same information, but with dummy data instead, and it would have more stats than the other actual algorithms we showed you. And we'll get to the hardware now.
Yeah. So in addition to the open data, what we also like to do is we have an Arduino with a air sensor. So as you can see right now for gas 1, this is measuring regular air. If I now stick it into this jar of CO2 and give it a couple of seconds, what we'll see is that it will actually, as you can see, our confidence for carbon dioxide increases and our confidence for air decreases. So we plan to combine this data as long as with the open data in order to help better inform work sites of potential gaseous hazards. Thank you.
All right, so there's going to be about 2 of you here, but who has kids that are in daycare right now? There's going to be, oh, there's one. Gotcha. Okay. So this probably won't resonate with most of you, but
a lot of maybe a couple, but a lot of parents struggle right now trying to find childcare, daycare for their kids. There's not really a central database available for them all to use. There's many different commercial opportunities and things that they could sign up for. There's a lot of paid subscriptions and things like that. But this is designed more for your average working parent that is having an issue trying to find where to send their kids. This takes real data from several New York State databases. Thank you to my friends for showing me how to use these. I didn't bring my laptop today, so I got to do a lot of this work from my phone, and it's kind of amazing how much work you can actually do. So this is actually a mobile app. Um, Basically, it pulls all the information here. So New York State, OCFS, U.S. Census Bureau, Google Maps. We can pull up the map here if it will work for us, which is great. Basically, you just would enter in your zip code here with the information, the number of children that you have, and their corresponding ages. You can do up to 5. If you have more than 5 that need childcare, you need extra help. But basically, you would click on one of these. These are all child care facilities. They need to be registered. And so they're all vetted. There's all a database for it. There's a separate one for New York City that would need to overlap with this. But essentially, they track if there's any record of any complaints against them, or if there's open issues, if they have an issue with their home being not safe for people to be in, if there's been anything that happens here. So it cross-checks that with a clean safety record, gives the capacity, the number of children that they can hold here. If it were working right, it would connect to a Google business profile if it is available here. Okay, so we played Children's Center here. I don't know if this still comes up, but it's got a 3.0 rating. Right now, it's got a direct link to their website, hours, and then some reviews here. She put garbage bags on our children for graduation. The teachers are innocent. So obviously there's gonna be a mixed bag of things here, right? So you're not you might not find exactly what you're looking for, but at least you're gonna get some insight into what's available. Um, this is currently available right now for Poughkeepsie. I'm from Minnesota, so I have no idea what that means. But I think it does a pretty good job here. It gives us a good idea of what providers are in the area. This is not do private. Right now, if there's anyone that has a Montessori or if there's anything like that, then it's not really going to be of any use. But I hope you enjoyed it.
Hi, everyone. I'm Brian. Really impressive stuff from everybody. I'm like kind of way out of my league here.
Hi, everyone. I'm Bryce, and Mike up there is also working on this with us. You're my boy. So every year, thousands of first-time home buyers in the Hudson Valley walk into a financial trap. They see a beautiful historic home, but they don't see the $15,000 knob and tube wiring failure or the lead pipes hidden behind the drywall. Standard home inspections happen after you're under contract, and by then, it's often too late. We built Inspector Go to give buyers and inspectors X-ray vision before they even step out of the truck. So who is this product for? It's for anyone who wants a home inspection. A home buyer, seller, real estate agent, home or fire inspector, or a renter. How many renters here have paid for a home inspection before signing a lease? I didn't. So we are talking about taking open data and empowering everyone to be their own home inspector. Some of the data that we're interested in includes construction age, type of construction in that era, such as what type of wiring? Is it aluminum, knob and tube, electrical panel? What about the lead pipes or asbestos? What about code violation history, certificate of occupancy, flood resilience, or permit history? In the app, all you got to do is enter the address of the property that you want to inspect, and you will get a threat score from our app. The threat score works by giving every house a base score based on its age. A house in the 90s will start at a 10, which is standard maintenance. A house in the 50s will start at 30, aging infrastructure. A house that's over 100 years old will start at 50 because it's
end-of-life fundamental materials. Points are added based on specific threats triggered by your Hudson Valley threat matrix, plus 15 points for lead service lines, plus 20 points for knob and tube wiring, plus 10 points for asbestos risk. If a property is recognized as within a historical district, the score is multiplied by 1.5. That's huge. It's huge because replacing a rotting window in a normal house is $400 in a weekend DIY project. Replacing a rotting window in a historic district requires an architect, a commission hearing, custom milled wood, turning it into thousands of dollars of a nightmare. High effort equals high vulnerability. We are Inspector Go. We're taking open data out of spreadsheets and putting it into the hands of people protecting our neighborhoods. Now here's Brian to talk about the tech stack in the app.
Okay, so this lovely image was made with Notebook LM, which is a really amazing product. I'm sure everybody in the room knows about it. I used Gemini to just build a that's not gonna work. To just build a static HTML page with some JavaScript and CSS. This is what it looks like. We wanted to make it mobile friendly, so we built it like this, and it's live on GitHub pages. So if anybody wants to use it, there's the QR code. And so if all you're really doing is typing in this is just pulling from Albany. It's OpenStreetMaps API. So you're just putting in your address. You have that fun little graphic there. Thank you. And there's your vulnerability score. There's your map. There's your year build, your architectural style, and estimated threat cost. Pretty simple. And then we put this button at the bottom for future use. Like, you would send that to a city database, for anybody else within the government to use. That's all. Thank you.
911, what is your emergency?
Hi, I'm Hasani, the EMT that would be responsible for the situation, but I feel uninformed and underprepared. I don't know about the traffic conditions, weather patterns, or other environmental factors that would impact my way getting to Srija. And additionally, I have no direct way to contact the hospitals that are responsible for continued patient care.
So introducing Apollo, which is an EMS optimization. So we have the problem of EMS wait times continuing to be 3 times higher in rural areas of the state compared to urban areas. For every minute that it takes longer for her to reach the hospital is another 7 to 10% loss in lives, and less than half of the EMS records are correlated perfectly with the hospital trauma records. Every second matters.
Right. So in developing our solution, we harnessed many different open data sets from the New York State website. So we were looking at traffic congestion, 911 end-to-end response times, dispatcher data, inequity, and social factors to look at how these various factors impact EMS's ability to get to various locations and conditions. So our solution streamlines the data to provide accurate information so that ambulances can pre-position. Essentially, this means instead of starting at their garages, they can position themselves at other locations to have greater availability and lower their response times, as well as establish direct communication to hospitals. So they can actually communicate with the doctors and nurses that are going to be continuing patient care.
Okay. So we got a heat map here. We pulled from publicly available New York City EMS data that shows certain neighborhoods that are at risk: Inwood, Pelham Bay Park, JFK, or beaches like Breezy Point that experience high emergency incidents, longer EMS response times, and it contributes to higher mortality rates. By strategically increasing the EMS hubs we plan in these underserved areas, we can reduce response time and save more lives. These are some of the areas. So Inwood has only a few highways going through it. It's hard to get in and out. This is a beach, as you can probably understand, it's hard to get in and out of. Pelham Bay Park.
as well as JFK, which is a very odd position if you need emergency care. Um, and if we pre-position these ambulance or EMS places closer to emergency care, we can increase survivability.
Sorry, as you can see, the second main facet of our app Apollo with this wireframe is paramedics can speak naturally during transport, while a real-time AI-powered platform captures and transcribes the handoff seamlessly in the background. The system extracts high-priority clinical data, generates a decision-ready summary, and pushes it to a live emergency room command dashboard, so the right team can be mobilized early and care can begin with greater speed, coordination, and situational awareness than ever seen before.
So we just have a quick demo right now. On one of our website here, basically you can kind of simulate certain traffic conditions. You can look at the weather, you can look at Medicaid access, the time of the day, population density, and then one of the things that we also included here was health outcome rates by the historical neighborhood grid. So that talks about socioeconomic factors, which is something that Google Maps doesn't really consider when you're routing an ambulance. So this is kind of just what our website looks like. And then here we go. So with this, you can kind of tweak out certain factors of where you might want to place your ambulance, and then you'll get what the response time looks like. So you can see that you can shave off a couple minutes through changing around your settings and positioning ambulances accordingly. And as we know from earlier, a couple minutes is many lives.
Okay, so first we created our idea, and then we utilized Cursor and Claude to help us search for available datasets and identify desired outputs.
So in the future, we think that this could be really valuable for revolutionizing how EMS systems and hospital systems work. And we think in the future we could provide direct routes so that these services and providers are able to find the most optimal route with all these factors that are considered. And we can use further data from the New York State data to update these informations. And we could also allow for live chatting, because right now what we have is transcription. So when EMS providers are in the ambulance, they can, transcribe particular things, and that transcription can be sent directly to providers, but we could have live chatting or telehealth to make that transition even more seamless.
All right, excellent job, everyone. Can we get a round of applause for all the gurus? Thank you for your passion, your hard work, and for your creativity. That's what makes me excited to do these things. So if you would please do a little survey for us so we can know how we did and how we could possibly do better, or maybe some ideas that you may have. Give you a minute to do that right now. I love the little dinosaur on there.
Well, judges are going to deliberation, so some slots would be available for you for your survey. Thank you.
And also, Parkit just came up with a working QR code if you want to try it out. And you can also discuss with them out there after the reception or just when we finish here.
So the big reception is coming after this. I have to tell you the secret, huge secret, while you're submitting your form, is John Storman's birthday. So that's what the reception is for. But also we're celebrating all winners, all teams, all participants. And it's also my birthday. What's the best deed ever I can do for myself, right? Thank you all for coming and supporting and celebrating our birthday. So you will have something to enjoy after this. And another call to action. We have a big posters, one big poster with GDG, another big poster with HV Tech Fest. Make sure each team go to these posters, and we will ask Richard and Heman to make group photos of your teams, because this will be something memorable. If you are not on this Slack yet, this is the QR code how to get to our Slack and continue talking to each other. Please make sure to enroll. This is our Slack. Slack is almost like the Discord. Okay? That's where you will find each other. That's where we were sharing resources. We made all these recorded, so we hope to post it on YouTube and share the link with you. You did awesome job. And each team will get a certificate. It doesn't matter what prize you will get, number 1, number 2, number 3, number 10. You're getting the certificate of completion of the hackathon. You did awesome job. And I know judges are struggling to choose who is the only one, who is the only second, who is only third, because you guys awesome. You impressed us so much. Remember our in kinds? We will definitely share the list with all teams, with all participants, with all your submissions, with our sponsors, and with the New York State agencies, government agencies. So that's your opportunity to be hired. Or maybe it's your opportunity to get your project finished. Being recruited as a team, being recruited as solo, I don't know. We will see, we'll find out, but we will share your contacts with everyone. Any questions? Do we need QR codes for survey? Yes, survey? Done with survey? Raise your hand if you're done with your survey. Oh, thank you. Thank you. We will follow up on that. We really appreciate you. And did you notice this is the actual photo, the real photo from today? We did make the Google album, the Google Photos album. It is shared. It will be shared on the Slack. Please add your photos there too. Recording photos, let's make it viral. We will do it on LinkedIn. We will share with you. Just you guys are awesome. We will create a huge buzz and vibe about this. Once again, thank you to all sponsors. Thank you, Arcos. Thank you, Nice Tech. Did you know that Nice Tech is giving the #1 prize? Okay. Thank you, Google, for supporting all that. Google is awesome. Not only because open source, not only because we are awesome, we are not working for Google, but we're actually using it. So it's win-win mutual. So they actually funded this event as well. Thank you, Google. What else do we want to say? Make sure to join our Google Developers Group. Okay? This is our GDG. That's what we do as volunteers. We have it for fun, for our birthday, for our career, for networking, just to find the best friends, our best friends. Pardon my English. Thank you. I not invited you to reception time yet. Let me check really quick with judges how much time more they need, because we really want you to be here before you go there. Okay?
So we're going to start with 2 honorable mentions, and then we're going to go from 3rd, 2nd to 1st place, okay? So for our first honorable mention, we have Red Route. Our second honorable mention goes to Lattice.
Okay, now we're going to our 3rd place. In 3rd place, we have Vision Track. No. And in 2nd place, we have Apollo. And in 1st place, we have, do we have drum rolls? In the 1st place, we have Go To. Yay!